Simple piece of information that you need to understand. For binomial rule, whether the number of repetitions is a fixed quantity or the number of successes is a fixed quantity. When we have the binomial variable, then we say number of repetition of n is fixed, and so the number of variable is number of successes in the variable, and so we define the random variable to represent what number of successes. Is this clear? And if the number of repetition is fixed, then one of the parameter will be that fixed quantity, which we define as and the other parameter always will be in case of the binomial type what? The probability of is this clear? And now we will calculate the PMF for a specific value of n, right? This PMF is defined. The random variable will always be x, and we will denote the PMF by p subscript bracket x, and this actually is a probability representing x as a value. Okay? So our goal is, if we define the PMF here, we will actually write down the probability there x to find this probability, actually we need to identify what is the number of successes. Yes. Right? And what is the number of failures? Since there are any repetitions and we have 8 successes, so there will be right? And how many ways these 8 successes can occur? Can you just and in earlier class actually, we discussed that the total probability, so the probability that there will be x successes and n minus x failures if we do not consider the order. Order is exactly which order the successes are occurred, we do not consider. There is a possibility that all the successes will occur at the beginning and n minus x successes will get the in the middle. We do not bother. In that case, what will happen? The probability of success will be p to the power number of successes and 1 minus p to the power number of. This indicates in general there will be 8 successes and n minus x failure. All of this should be occurred. Actually, what is inside here? You have a tree diagram. In this tree diagram, you have a path, and that path has 8 successes and n minus x failure. If you consider in the diagram, say if you consider n is equal to 3, then actually the first one would be a success. So the right side one is success, and the left side one is failure. Here you can have a success, have a failure, have a success. In the third item, you can have a success, failure, success. Right? So this indicates if you have 3 successive successes, then actually you are traveling in this path. And the probability will be p times p times p. And if you have a path like this, what is this? A failure followed by a success followed by a failure. This is 1 minus p times 1 minus p. Since we are multiplying irrespective of this order, you can write p times 1 minus p to the power. And more importantly, this path And this path however, they are the same path, but they have the same probability because both the two paths have one success and one failure. And this will result in similar probability if we do not consider the and the probability does not have different ones. The probability does not change. Eventually you are multiplying it, so it is right. So what we can write here, the binomial probability or pf of x can be like what? It will be p to the power x 1 minus p to the power n minus x. And how many ways that can occur? You understand this? Any questions? In the second, if you consider geometry, so what is the variable here? Number of repetitions or number of successes? Okay, and the constant is number of how many successes are there? Only one. So we have a parameter 1. Since the parameter is 1 constant actually, it does not exist in the array. Just for simplicity, only parameter is b, and number of successes will be 1, and number of failures will be. Since the random variable represents number of repetitions x, so x minus how many ways that can occur? In a geometric distribution, when you end up with a single success, always you will have a single path. Because a number of values followed by so if you consider the success is the upward direction and failure is the horizontal direction, you will have a success only when you go to the upward direction. Right? And so for this value of x, there is a single path. And that's why the number of ways is 1 and the pf of x will be p times 1 minus p to the power. This is clear. For Pascal and variable, what is the constant? Number of repetition is constant or number of successes? Will you plot more than one success? Is that a success? And the probability which means a success occur is e. Right? And number of successes a, and total number of repetition is actually what I define is the random variable here. In this case, the random variable actually in this case random variable x is the number of repetition. Here x is the number of repetition. Here x is the number of right? Then number of failure will be expensive. How many ways that can occur? Just for now, I will later on I will show you. It will be x minus 1 and I think I show you that for you. Here's the one. Now, if you can actually understand this technique, then you can differentiate all these three random variables very easily. And you will put out. This is correct. Once again, any questions? understand this study, you can differentiate these two elements very clearly. Okay. Okay, question. Then let us see. I will skip this slide because the principal parts of this actually text have been explained. Just here some more elaboration are here. I think you can read it out. So for a geometric distribution, if we consider that we send a packet in the transmission concept, we send a packet, and for simplicity, if we assume that field is on the path, then what will happen? We can have this diagram. What does this diagram show? This diagram shows that a horizontal line in a Bernoulli experiment, these are the atoms, meaning each of these atoms is a Bernoulli experiment. And number of Bernoulli experiments is condition. What is the condition here? The condition is until first success will be completely Bernoulli experiment. What happens? A horizontal line indicates a success and a downward inclined line represents
failure.
So in the first attempt you are lucky man to get the success, that's equal to 1, and the probability will be, if you have a failure, you come to this point and actually this records the probability 1 minus. And in the second attempt, you have the same options, either a success or a failure. If you have a success, then actually the number of attempts that you need to get the first success is 2. And in that case, actually the probability becomes probability of this part. This occurs with probability 1 minus p. This occurs with probability p. So it is p times 1 minus. By this way, we can see that the probability is times 1 minus b to the power x minus. That means if you get the first success in the x attempt, it simply indicates there are x minus 1 failures. And after that failures, you got the first success. Out of this x attempts, there are x minus 1 failure and 1 success. And now, if you come back here, then we see the first one is half. Second one is half times half. Considering that the probability is half, we have half a square, half cube, and this is what is the geometric space. And so the random variable is defined as the geometric random variable, and the distribution is defined as the geometric distribution. Furthermore, we usually use a term family of distribution. Did I discuss this one in an earlier class? We use the term family of distribution to indicate that I showed you that, right? We usually write geometry in this way, right? X, then this character is known as 3D, right? Then geometric P. It says X is distributed as this character is pronounced as distributed as. So X distributed as geometric with diameter P. Right? Is distributed as geometric with diameter P. And we call it a family of distribution because for each value of P, we have a different geometric distribution. So if you have 1,000 different values of P, then actually you have 1,000 different distributions. And so we call it as a family of distributions. This is clear. So whenever you will encounter this term for the geometric family of distribution, this is nothing but same distribution, but for different values of P, you will have different. Okay. Now, finally, this is the distribution. The PMF we write in this way. PMF of X This one, x should be greater than equal to, or you can write x equal to 1, 2, right? And it is 0 elsewhere. Now, this is the curve. What does this curve show? This curve shows the probability that you have the first success in the first bracket is P, when P equal to 0.5, when you need 2 attempts, the probability actually decreases. So, we will have it in the is this clear? And if you consider this point 3, similar characteristics is shown. Later on in the 7th semester, you will have a course where this probability function explore. And the geometric distribution sometimes is called memoryless, but in the of time, you will see. Memoryless means you know what's the movie, doesn't it? What is it? Forgets things. So this certain variable forgets things. If you consider the average lifetime of this bulb, so 6 months. After 6 months, the average lifetime still remains as 6 months. It also forgets that it has already served 6 months. It has this memory in principle. Okay, now the CDF of the geometric random variable is defined mathematically. You can get it. Our job is not clear. You will find it in Wikipedia, and accordingly, the graph shows like this. It is a staircase thing, since you said discrete random variables, and eventually it reaches to 1 at some points. Actually, it keeps going. So for different values of P, we will have different distribution functions. Any questions here? This expected value of the geometric random variable can be calculated. We do not need it. What we need is the value. And the variances and will be available at the next level. Okay. So I did ask this question here.
Sampling frequency will be F1. Therefore, I will 4/3. Frequency জন্য আচ্ছা দুবার রিডিং নেব।
No. Then, in the next, you will ask. It will be better for us if we could see that question before the exam. Then we will be actually in a comfort.
ওভার এখানে বেশি পয়েন্ট নিচ্ছে সিরিয়াস ওটাই বেশি পয়েন্ট নিচ্ছে
You will not get to know.
আন্ডার
That does not mean whether number of repetitions is a variable or number of series is a variable.
ঘুরে যদি নর্মাল মারি 12 তাহলে হবে
You need to understand.
ওভার মাত্রা
So all the distributions will be given there with what?
এটা বুঝাইছে
This one will be. This one will be. Right? So we will not need to memorize. Now, I did ask this question, right? So, we will attempt to solve the problem. Let's say when the 3 zone toss, the success occurs with probability. What do we mean by the term success? The success here means all the coin do not show the same amount. So if failure occurs with probability Q, right? What is this? All the points showing. So what is the probability of a hit? Half. So what is the probability that all the 3 points will show hit? What is the probability that all the points will show is? You can do it other way around. What is the other way around here? When there will be a situation where 3 points are lost, what is the probability that there will be 2 hits in 1 hit? Probability. There will be 2 hits, 1 hit, or 1 hit. We have a random variable. Let's see, what is the random variable? That represents number of hits. So what type of random variable? 3 sounds are tossing coin is. Y counts number of hits. Right? So y is equal to number of hits will be 0, number of hits will be 3, 1 and 2 as well. So y is a random variable. What type of random variable is? Is it a binomial? Right? So number of success is fixed or number of repetition is fixed. Number of repetition is fixed. The coil is tossed 3 times. So number of success is now. So Gauss is here. Right? For binomial, x is number of type of number of successes. So what actually is a binomial random variable? Indeed. And so it is binomial with parameters here now. Then you can calculate the probability that y has a value 1 or the probability that y has a value 2. Where the value 1 is what? 3 choose 1, half to the power 1, 1 over half to the power 2. Where the value 2 is 3 choose 2, half to the power half. And then if you add these two, you should get this number. Now, you come back here. Original problem. Find the limit of the number of rounds. Let x is the random variable that represents the number of rounds. To get the decision. So what are the possible values of x? What I mentioned here, our steps are very simple. We define the random variable, we define the set of possible values, we calculate the probabilities for each of the values, and then we write them again. Steps are very simple and direct, right? Okay. So what are the possible values? How many rounds of tossing they need to get a decision? then my peak loss will be here, and in non-zero probability exists. And in non-zero probability exists for that, which might be 0.10 trillions of zeros or more than that, but a non-zero probability exists for that. They will keep the same. Anyway, someone sleeping while watching the movie. So now the question is, what is the distribution of X? X distributed as, because the number of repetitions or number of successes are fixed. Now how many successes? So when number of successes is 1, we actually are going to geometry. So it is geometry. And what is the value of P? So writing this one actually is as good as this one, but we prefer this one in the exam. But you will be writing, asked to write a PMF. You can say X is geometry, and so the PMF is, it is at the left side of the question, which is now what is the expected value of X? Is this clear? So the problem is not simple. It is not difficult. If you have the knowledge of all the elements, you can easily fit it to the geometry. But there is a tweak here. The tweak is the P itself is coming from another random variable or another probability. Okay? So, as I was mentioning, that a non-zero probability exists that will keep us. Say, a computer network protocol is designed in such a way, it will be trying to send a packet to another computer, and that computer is somehow turned off. Then what will happen? The networking functionalities will be blocked for trying something that is not possible. That's why the protocols are designed in such a way, after a maximum number of retries, that packet will be dropped and the protocol or the mechanism or the function or the material or the behavior will actually try with the second packet. Next. A geometric kind of variable actually in principle has a value that goes up to but not into the but in reality it is not physical or not actually something you can tolerate. That's why there is another option of a geometry. We call it truncated geometric variable. Right? What is it? Truncated. That means at a particular point we force the geometric variable to stop. I have to go to the yeah? Let us learn from it. Awesome. So now, I keep doing that. What is some part of this? Right? And actually, you do 2 minutes. That's what the class will be extended to 2 minutes. So, in case of the geometric distribution what we do with force. The random variable to stop at a certain point. Let's say we stop at R. Then set the possible values of the random variable will be 1, 2, up to R. And what will happen at this point? After R minus 1 successive failures, the system will try one more time, and if a success occurs, it will end up with a success. So, success after R minus 1 failure, or there will be R successive failures. So, it actually violates one condition of the geometric distribution. The geometric distribution always says we will end with a success. But here you can end with
failure.
no success. Is this clear? And we call it truncated geometric distribution. The question is, what will be the for all values up to R minus 1, it behaves like a geometric entity. That's why we have the first condition. P times 1 minus 2 to the power x minus 1 for all values of x up to R minus 1. Is this clear? When x is equal to R, then actually the probability is 1 minus 3 to R minus 1. Question is solved. You can consider this one in the way that with probability 1 minus p to the power R minus 1. What does this probability mean? There will be R minus 1. And R minus 1 failures will always end up being R transition. Right? When there is R minus 1 failure, you are here and it will go for all pattern. So the question is, what is the probability that x is equal to R? That means you attempted R times. It's the probability that you or you can consider it another way around. By applying the law of the probability, you can consider that x is equal to R will be resulted if the R target is a success. The probability that you have a success after R minus 1 consecutive failures and one success, or you have R successive failures. Both the probabilities will be added, then you will get the same. Okay? So this is the distribution for truncated geometric pattern. Now, if you want to talk, you have been thinking about this previously for the last 10 years. Right? After the class. Or you will come to my office tomorrow. Since nobody has problem, okay, the variable distribution that we have actually already discussed, everything related to it has the element. Right? The very first question is, why do we call it binomial? There is a binomial theorem. You know? This binomial theorem has the similar structure as this. What is the difference? Right? What is the difference? The summation is in the binomial theorem, but the summation is not. The summation is not. This theorem says probability that x is equal congruence? Or more specifically, if you want to calculate that, find the probability that x is how will you calculate the probability? This says that what is the probability that there will be less than or equal to x successes, right? There will be less than or equal to x successes. That will be the probability of 0 successes, plus 1 success, plus 2 successes, plus 3 successes, up to x successes. And in that case, this probability is equal to x is equal to 0. You cannot have both x. I equal to 0 to x, then choose I into I, 1 minus
then I took 0.50 to measure.
right? So now you can see this and this are the same. Next one we call it the binomial distribution. How the probabilities are calculated based on this diagram? I guess I explained it in chapter 1, where actually we only considered the first three. You can just extend it for getting a purpose. Okay? And formally, the PF is right here, and the CDF is the CDF is found by summing of the probability PFs up to the value x, as it says. What is the expected value for the binomial table? And the variance is standard deviation is actually standard deviation is not needed because always the standard deviation is square root of the right. The curve here, the probability curve actually for binomial is a distinct kind of the probabilities are defined, but one of these here is similar to the main part. Not exactly. And what actually happens? Probabilities, if this is the set of values, there always exists a k. Up to k, the probability actually increases. Then the probability. Then the probability increases. Right? Always this scenario. And most of the cases, k actually sits in the middle. There is a possibility that we have a similar probabilities. If the number of species equal to 1, 2, 3, 4, 5, 6, 7, 8, or what difference does it make? Actually, if we compare this quantity, you can see that the PMF of x for the value k and the PMF of x for the value k minus 1. That is, if we find the ratio between the PMF for a value k and x previous anyway, then actually you can see this probability is what? N choose k, p to the power k, 1 minus p to the power n minus k, right? And here, n choose k minus 1, p to the power k minus 1, 1 minus p to the power n minus k minus 1. Is it? Okay? That's one? And this actually results in this one. Who is asking for the assistant? N minus k plus 1 times p and k divided by 1 minus k. Right? Actually, if you just process it, you will end up with this one. And then, actually, you can see that this ratio actually, this one here, if you erase this one, then if you focus here, the ratio actually results in this one. It will be greater than 1 when this quantity is positive. And when this quantity is negative, it will be less than 1. And when this quantity is 0, then actually both of the terms are right, because they are equal to 1. So when this quantity is negative or positive, that depends on this quantity. If k is greater than this one, then this is, and k is less than this one, and accordingly we can find a value of k for this star within this. Right? This is the problem, but it is good to know. So now, if you have any question, then you can ask for binomial change. Because yesterday we defined it very clear. Today, first we define everything related to binomial. Then actually we add some formula that you might be. If you have any questions, go ahead. You will listen. You need to understand this one. Okay, what is that? When this quantity is equal to this, then this quantity is greater than this quantity. This quantity is less than this quantity. This quantity is less than this. See? Comes from here. Not one yes, if the ratio is greater than 1, then this value is greater than 1. If the ratio is greater than less than 1, then that means the numerator is less than the denominator. This is simple one, right? So, what is negative binomial? We already discussed the behavior for the negative binomial, right? One thing that I did not discuss, I state that the number of ways we will have the thing was x minus 1, right? Y is actually to derive the behavior for the binomial random variable, we need to consider what are the variables? In a binomial, negative binomial random variable, what happens? Number of repetitions is variable and number of successes, right? And number of repetition is x. So this is success. This is. So let us assume an example. You toss a coin until you get 3x. This of the horizon, vertical line indicates a toss. Let's say you got a head here. Hey, right here. So you got a head here. You got a head here. And you got a head here. Right? now let's say the level 4, 5, 6, 7, 8, 9, 10, 11. One important thing that happens here is in case of both geometry and negative binomial, you always end the binomial term with success. It is not possible that you already got 3 heads and you will keep crossing something. As soon as you get 3 heads, you stop. In case of geometry, as soon as you get the first head, you stop. So, in this figure, one identification is that we have 2 events. One of the events is 2b x is equal to 12, meaning that you get 3 heads in 12 attempts. You have a success in the 12th attempt, and you have 2 successes. You have 1 success, and you have 2 successes. You have 1 success in the 12th attempt, and you have 2 successes in 11. 2 successes in 11. Right? Now, if you define this one equal A and this one equal B, you got that over. So not only you are polluting the environment, but also your neighbor is sometimes we have 2 events, right? We define the events A in n minus 1 try or x minus 1, whatever we consider. There will be a minus 1 successes. Is it acceptable? We do not care about the orders. In k minus, sorry, we obtain k minus 1 successes or head in n minus or x minus 1. Then we have a random variable here, right? What is that? Is it binomial, geometry, or Pascal? It is binomial because number of successes is the quantity we use for number of trials, etc. So, what is the probability that we will have 2 successes in x minus 1 trial? It is binomial, and we can readily write that x minus 1 and how many k minus 1 probability will be k minus 1 and number of failures will be 1 minus k2 x minus 1 minus k plus 1. Is this clear? So this is the probability of occurring event A based on the this one? Yes. Binomial distribution. On the other hand, we can consider that there is a success here. 1 success in 1 attempt is actually occurs with the probability. Right? With probability P, you will have a head. With probability 1 minus P, you will have a head. So what is the probability that you have a success here? Now, if both the events A and B occur together, then what will happen? You will get 3 heads in exactly 1 attempt. If you have 2 heads in 11 attempts and 1 head in the 12th attempt, and the probability will be the product of here. So the PMF of x for the value what? X will be equal to the probability of occurring event A times probability of occurring event B. What is probability of A? It is x minus 1, k minus 1, p to the power k minus 1, minus p to the power. Right? And what is probability of B? This P actually cancel out. is minus 1. And so we end up with what is the minus 1? What is this one? This one. Finally, the payment will be this one. So we understand. And why actually we have S minus 1 here minus 1? Since the last one is fixed, we have the binomial distribution inside the cascade distribution. Actually, it is called the negative binomial because it is opposite. In binomial, if there are n trials, we look for n successes. In negative binomial, there are fixed successes. We look for it. Probability of x. Right? Now, hypergeometric distribution. This is one of the most important distribution and very interesting. Let us consider, or actually for all this, I could have actually explained this with the example of balls, red and blue. In shortage of time, so I could not go there. Now, let us consider the point. You have a box and you have red balls. Unfortunately, the equations is written in such a way, actually in one of my previous documents, they are actually, we have the green balls. Let us consider it here we have the green ball as well. Instead of we have R green red balls and G green balls. In total number of balls is. Now the question is, pick 8 balls randomly. With replacement. To pick 8 balls with replacement and without replacement. With background with replacement, we will pick a ball and we will count with what's the color of the ball and we will count how many red balls so far picked, how many green balls so far picked, and then we will pick the ball. This is clear. And in case of without replacement, we will pick the ball. Okay, we will pick the ball. So the number of balls will be decreased by 1 piece. So you cannot pick the balls more than. Since there are plus G balls, you can pick the balls at least. If you go for without replacement. But if you go for replacement, there is no problem. You can pick the balls as many times as you want. Also, you cannot pick more than R red balls if you go for without replacement. Since there are at most R red balls in the box. So, question is, find the probability that exactly X red balls are picked. Now, in case A, what is the probability that exactly X red balls are picked? What? X is a random variable or constant. We pick the balls 10 times. X represents number of red balls. So how many red balls you pick? Is variable or fixed? Next. It's variable. You cannot pick a red ball. Say there are 1 million green balls and 2 red balls. If you pick 10 balls, probably is very less than you pick. Now question is, who can answer for A, X distributed as number of repetitions. And we look for the number of successes. So if the number of successes is our quantity of interest, then there is only one factor. That is, if number of repetitions is our quantity of interest, then there are two. For long success, it is unity. For case success, it is these three sentences. So it is what? What is the parameter? One is M, and P is probability, which is equated, which is the ratio of number of balls to total number of balls. Right? Since you are hitting the ball. Now, when you hit the ball without hitting the second one, then actually this distribution X is this is hypergeometry of three parameters. Sometimes you might have only one of these two values. The other one is given in terms of the total force. Meaning there are in a box there are 20 volts of which 15 are ready. You can make the number of number and number of volts. Right? And in that case actually it is realistic. Why is so? From a set of R plus G balls, how many ways you can pick N balls? This actually is calculated based on some combination. So how many combinations are there? If there are R plus G balls, how many ways you can pick N balls? 6 R plus G squared. If there are 7 balls, how many ways you can pick 2 balls? 7 choose 2. Out of this, how many cases you will choose exactly X red ball? It will be R choose X. And the remaining N minus X balls are green. So how many ways you can pick along the G balls? N minus X. So this product gives you what? The number of ways by which you can pick exactly X red ball and N minus X. This is talking about it has it in the middle, right? Gymnasium.
Yes, sir.
So this ratio actually gives you the probability where you ended up with N balls of this exactly this balls are. Okay? And the expected value of M and X are here, it is also in there. Okay, there are two more random results before we finish this chapter and we wrap up the syllabus for the midterm. So, the first one is Gaussian random variable. What is a Gaussian random variable? Actually, we can write a book on Gaussian random variable.
Nice.
At least 2 chapters. That's why it is too big, and hopefully it will be covered in detail. The possibility exists though very slim. I will take that course. Very slim. Where actually the Gaussian distributions and associated things will be covered in detail. One chapter will be there. For now, what we consider about Gaussian distribution? Actually, it is an approximation to the binomial distribution. Now, let's say you want to calculate how much this value will be. Can you calculate by number? Will the calculator allow you so? So, if there are situations, let us consider an example where what happens, a shopkeeper who actually is good at math wants to find the probability that in next 10 minutes, whether there will be a customer in his shop or not, for next 2 minutes. To do so, he actually tried to apply the binary method. How? He considered that on an average in an hour, there are 10 customers. Right? So, then in a second, what is the probability there will be one customer? 10 divided by 60 times 60. Is this clear? In 1 hour there are 60 minutes. In 60 minutes there are 60 seconds. And in 1 hour, on an average 10 customers arrive. So what is the probability in any split second there will be one customer in his shop? Now he wants to calculate that in next minute, in the next 60 minutes, there will be one customer. So this is the value of it. Now he wants to know the probability that in the next 60 seconds, what is the probability there will be one customer? Then it is what? You can apply. So there are what 660 to the power 60. So mathematically it is correct. But this practically it is. Now, when these scenarios occurs actually, what we do, we approximate the binomial distribution. What we do, in approximating the binomial, we actually identify the average arrival rate of C. So every time we want to do that, what happens? There is a thing that some event occurs, some phenomena occurs. And we actually have the knowledge about the average rate of occurring such. For example, average number of cars arrives in the particular part. Average number of customers arrive in a part. Average number of patients arrive in a outlet stop. Average number of patients arrive at a hospital. Average number of customers arrives in a guests arrive in a community center. So all of this there we know. What we have a quantity we call lambda. Rate of arrival of something per time. Now, what we want to do, we want to know the exact probability of arriving an exact number of customers in a time period T. Right? Here it was unit time, lambda was defined with respect to unit time. We want to know about that person wanted to calculate the number of arrival of customers in 60 seconds. Oh, should be for now, going back this one will create so now, so what is the average number of arrival in this T time period? It will be lambda. What does lambda indicate? Lambda indicates average number of arrival per unit times in 1 minute. And if you are considering that in 10 minutes how many customers are there, then lambda indicates still the average quantity. Average number of arrivals in 3 minutes. In 3 times. And once you have this one, the Gaussian distribution says that there will be exactly X customer. If T time minutes is equal to, okay, let me write it here. Payment of X for the value X will be lambda T, capital T, to the power x e to the power minus lambda t x factor. X could be greater than or equal to
0.
In many books, you will find that a quantity is defined called alpha. Alpha equal to lambda. And x is whenever we write the image, we have two columns here, right? The first column indicates, second column indicates, right? So here, always there will be condition. So for which value this function is applicable. You can sometimes write by absolute probabilities. Sometimes you can write it as, say, this, a function of x. Then whenever you will write it, you need to mention for which values these probabilities are applicable. One of such is here. This equation is applicable. Value for its number of variables cannot be given. Yes, and for what type of problems we actually finish? You can use this. Let us consider this very simple example. The number of round numbered calls that arrive with a certain location as Poisson distribution. Unlike the other distribution that we discussed earlier, where will not be mentioned that it is binomial, it is geometry, but for Poisson it has to be mentioned either as Poisson distribution, non-Poisson application, or in Poisson applications, another thing will be some average variable method to be. So when this average variable rate will be given, you will have to understand this until you cover another enough variable system exponential. But now, so distribution with the rate lambda equal to 2 calls per day. Find the probability that there will be at least 2 round calls by 2. Can you solve it? By tomorrow, how many days? 1 day or 2 days? So we are sitting Thursday. By tomorrow means Thursday and Friday. So C equal to what? 2. What is the value of lambda? 2. Lambda t equal to 4. So the probability that x is equal to x, meaning the PML of x will be what? Lambda t to the power 4 to the power minus lambda t divided by x, right? Yes. So lambda t has a value? So what is the value of lambda t? 4. 4 to the power x to the power minus 4 x. Now you are asked to find the probability that x is less than equal to what you are asked. So you are asked to calculate probability that x is greater than or equal to 2. Then actually you need to do what? Summation x is equal to 2 to infinity. But an intelligent student will do what? And this includes probability that x is equal to 0. When x is equal to 0, from here you know this quantity becomes 1, this quantity becomes 1, this is equal to 4. When x is equal to 1, it is 4 divided by 1, 4 times equal to power minus 4. So, here is the answer.